This is a Nature of Science video. So the original question is, what is science? And the definition for science is a self-correcting process, a way of doing things, of recognizing and detecting patterns in nature and describing these patterns. So as humans, we have evolved to detect patterns. So if you look at the picture off to the right, you'll see the picture of the Mona Lisa, but it is a mosaic. That's not a picture of the Mona Lisa. It's a lot of pictures connected together, and your brain just recognizes it. Same thing with this photo. It's just a lot of black splotches, but you can see that there is a outline of a dog there. Also with this one's a vase. You can also see two faces. Same thing with numbers. So if you look at this pattern, you can see here that it is just the two numbers above it added together. It's called Pascal's triangle. So science is all about pattern recognition, but not all pattern recognition qualifies as doing science. Think back to that black box experiment. So for this lab, you're trying to determine what is inside that box, but you cannot open it. You just have to run certain tests and narrow it down. So the question for this is, based on the tests performed, what do you think is in the box? Explain the answer. And could you ever be 100% certain as to what is in the box without opening it? Why or why not? And in your own words, how is the black box experiment similar to science? So you would need to open that box in order to be 100% correct, but you're not going to, ever. You're never going to know what's inside this box. And that's because the black box serves as a metaphor for science. So, in real life, there is no physical box that can simply be opened to reveal what is inside. In science, nothing is ever known for certain. Science cannot prove anything correct or true. Science only provides a description of the patterns found in nature and is based upon well tested hypotheses. And these experiment results are reproducible and verifiable by anybody. So, should you be bothered by the fact that you will never know what is inside the box? And the answer is yes, but only a little bit. Now, here's why. If somebody told you that everything and everybody are made up of atoms, you already know this, but you knew this by somebody telling you. And no one has ever seen inside of an atom, so how do we know what's inside? And the atom represents the black box. So this is a good example of how the black box represents science. The exact contents of the black box will be forever unknown to us, but by carefully conducting controlled experiments in which the predictions of our hypotheses are repeatedly tested, we should feel fairly confident that we have adequately described the contents. There should be a lot of objects you know that are not inside the box based on size, weight, shape, sound. You may make an educated guess as to what is in the box, but you will never know if you are correct without opening the box. There is no physical box that can be simply opened to reveal what's inside in the world of science. So science can never prove something correct or true. Science operates under one simple principle, and it is known as the principle of wrongness. Now, if someone makes a claim, in order to be scientific, there must be a test for wrongness. So being correct and being not wrong are not the same thing. There's no such thing as true or correct. You're just not wrong yet. So let's look at some of these scientific claims. Someone says blue light increases vegetative leaf growth. Was that a scientific claim? Well, yes, it is. There is a test for wrongness. Now let's look at this one. Atoms are made up of smaller particles. Is that a scientific claim? Well, yes, this is a scientific claim. There is a test for wrongness. What about this one? Avengers Endgame is the best movie ever made. Well, no, that's not. Opinions are not scientific claims. There is no test for wrongness. But this one, ghosts exist. Well, no, that's not a scientific claim. Statements dealing with the paranormal or afterlife are not scientific claims. The absence of evidence is not the evidence of absence. There is no test for wrongness. Now, what about this one? The earth is flat. Well, yes, this is a scientific claim. It just so happens to be a wrong scientific claim. You can test this for wrongness. How about this one? Finding a four leaf clover will give you good luck. No, it's not. Right? This is not a scientific claim. Statements dealing with superstition or luck are not scientific claim. There is no test for wrongness. Now, this one's interesting. Consuming margarine and Maine increases your chance of getting a divorce. Well, is that a scientific claim? If you look off to the right, you can see that there is some sort of relationship between divorce rate in Maine and consumption in Maine. Well, this is not a claim. Correlation does not equal causation. There are just too many variables to consider. There's not really a test for wrongness. So, science is not about who is right, but rather what is right. There's no room for human ego, and just because you want something to be true doesn't make it so. It is not about accepting things on authority. You must question everything. So let's look at another big question. Is saying the sun orbits the earth a scientific claim? Well, yes, it is. There is a test for wrongness. It just happens to be a wrong claim. So let's look at the world's greatest physics demo. This is a video of someone performing the world's greatest physics demo. And in this video, there's just somebody dropping a penny over and over again. Now, can you explain the world's greatest physics demo? So a lot of people just say, well, it's got to be gravity. Well, Richard Feynman says, well, just because you know the word to something doesn't mean you know how it operates. Just like if you know the word for a bird in every single language, you don't know anything about that bird. So, yeah, saying that a penny dropping, just saying gravity doesn't explain it. It's just a word and doesn't explain why the penny falls. So let's look at this concept of wrongness, right? So the ancient Greeks thought that heavier objects being made of more material returned to the state of rest faster than lighter objects. They thought heavier objects fell faster than lighter objects. So is that a scientific claim? And the answer is yes. There is a test for wrongness. So if you drop a ball on a piece of paper, you'll see that the ball will fall faster. So no, we did not prove the Greeks wrong. But were the Greeks correct? The answer is no. Remember, in science, there's no such thing as being correct. Now, a simple test that we can do to show that this is true is to wad up the piece of paper and repeat the experiment, and they'll fall at the same rate. Now, there's also another problem. Well, the moon and the planets didn't fall to Earth in a straight line, just like things fall on Earth. Well, why did they move in circular orbits around the Earth? Now, this is their assumption. There was a fifth element, and in the earthly realm, their natural motion was a straight line, and the heavenly realm was circular. Were they wrong? No. Based on their observations, if you look up, everything in the sky seems to go in a circular motion. Everything on Earth falls straight down. So they weren't wrong, but they were not correct because you can never be correct in science. So Newton came along, and Newton made another claim and said, well, gravity just is mass being attracted to other mass, and he found a way to calculate it. So is this a scientific claim? And the answer is yes, there is a test for wrongness. In fact, you can do this experiment on your own and you can see mass being attracted to other mass. Now, what he did was he unified it. He explained orbit. He explained why the apple falls down. There are not two separate realms. All bodies in the universe must obey that equation. And was he wrong? No. You can do the experiment to see this. Now, was he correct? Well, the answer is no, because in science, nothing is ever correct. But there was a problem, though. Mercury, after Mercury orbits the sun every 88 days, and it arrived half a second earlier than it was supposed to, based on Newton's equation. So this isn't good enough. So just think back to playing a game of chess without knowing the rules. You're trying to figure it out, and sometimes something doesn't make sense. That's what scientists investigate. So Albert Einstein claimed that what we perceive as gravity, in fact, arises from the curvature of space and time. And is this a scientific claim? Well, yes, it is a scientific claim. There is a test for wrongness. So what he thought was that, well, if the mass just warped space and time, then light should bend around objects. It should be affected by gravity. Now, so what they did was they set up this experiment where they could see the starlight bend around the sun by waiting for a solar eclipse. And what they noticed was that when they compared where the stars were supposed to be and where they were during the solar eclipse, the light actually bent around the sun. So this gave way for Einstein's theory of general relativity, which is a whole new way of thinking about gravity. Now, was he wrong? No, he wasn't wrong. Light is affected by gravity. But was Einstein correct? The answer is no. It can never be correct in science. The universe doesn't have a box that can simply be opened to see if Einstein is correct. So that's why the final thoughts is there's too much unknown in the universe to take a break from learning. Get out there and question everything.